Hi, and welcome to part 11 in creating a DLX architecture simulator. In this episode, we're going to continue working on our interpreter, which we're writing in C Sharp. Um, Last time, we were able to open a file, read it, get the opcode, and then also get start processing the registers, and then write them to a binary file. So today, we're going to continue on with that. So what we're going to start by doing is we're going to start by adding in a dictionary for the uh, function codes for the opcodes that have for the R-type instructions, since they have opcodes of 0. So func codes equals new dictionary, and then we're going to have to copy these all over, and we're going to want to paste them in, and we're going to want to change these values to what they are in the document. So we'll have 4, 6, 7, 20, 22, 24, 25, 26, 28, 29, and then 2A and 2C. So now we can use those to get the function codes from our using our interpreter. So we're going to rewrite our interpreter a little bit to write these things a little differently. But what we're going to first do is we're going to switch our stream writer to a binary writer, and we're going to make this to a binary writer, and we're going to go file.open, path, and then file mode.create. So this is just going to convert it to a binary writer, which will write binary instead of writing text. So instead of writing the actual value in a decimal, it'll write it in binary, so we can read it into our simulator much easier. And then we'll open up program.cs, and we will go fh.write file. We need the path, which is going to be binary. We're just going to call it binary for now. And then our instructions are going to be i.binary lines. So just like that, that's all done. So now what we need to do is we need to write out our interpreter, which we are going to refactor a little bit while we're doing this. So we have read in the assembly lines, and then we loop through all we store the lines read into a thing called assembly lines, a list called assembly lines. We loop through that list and we handle each line, and then we convert that line to binary. So convert to binary is where we're going to start changing things up. So we're going to remove this. Actually, we'll leave it there for now. So we're going to split, and then so this is going to give us essentially this just gets our first value. So let's change this a little bit, and let's go private uint 32. We'll get opcode, and we'll have a string opcode. We're going to have a private uint 32 get destination string register. We're going to have a private uint 32. We're going to call it get source 1 string register. We're going to have private uint 32 get source 2 register. We're going to have up here by opcode, we're going to have private uint 32, and we're going to call it get func code. And then finally we're going to have private uint32 get value. So actually let's just change these all to just get register. Okay. So this one's going to return so so we're going to go return c.opcodes opcode. This one's going to be return c.funccodes opcode. Func code, sorry. This one's going to be return uint32.parse, and then we're going to go register, and this is going to return uint32.parse value. So that's it. So now what we're going to want to do is we're going to want to split this up like we have. So we're going to want to, so we're going to have, so we're going to want to get string opcode equals regex dot split line dot toLower at s plus zero. So that's going to get us the first one. And then okay, so that gets us the first value, which will be just the opcode. Then what we're going to want to do is we're going to want to say string array arguments equals string line, let's actually, we might need to do we need another one? Let's go line dot, I think we can use replace opcode with nothing, and then we'll go regex dot replace line dot replace, and then at s plus, and that's going to be arguments. Perfect. Okay, so now we can go op uint32 opcode equals get opcode uint32. Actually, we don't need that yet. There we go. So let's do that right now. And now what we need to do is we need to process our arguments. So if so let's open up DLX sim. So if we have 3 arguments, or we have 3 arguments, we're going to need source 1, source 2, okay, so let's see, we need so we'll have Okay, so if, alright, so let's go, so let's do uint32, we'll call some process arguments equals, or args split equals, alright, let's just go down here, let's just use process arguments for now. So it'll take in a line still, so we'll say uint32 args equals process arguments. Alright, so let's move this up here now. Okay, so let's say regex dot split and then we want let's switch this to args cannot access non-static method split in static context. Well, good thing we're not. So string let's call this trimmed equals regex dot replace line that works. Okay, fine, whatever. Okay, so if args.length equals 1, then we want to return get value args 0, else so if we don't return that, then we keep on going. Okay. So now what we want to do is so I have a better test file written here. So the first one's always going to be our destination. So we want our destination to be the first one, which means we want it to be quote-unquote last. So what we're going to want to check is we're going to want to check if args2 dot 0 equals r. So this essentially is the third argument a register or value. So if it's a register, then we want to so we're going to have uint32 so we're going to have uint32 value. Let's create an array of values equals new of size 3. So we're going to want, so this is argument 2, so we're going to want values 2 to equal get register, and the string is args2 1, or args2 dot substring 1. Else values 2 equals get value args2. Perfect. So this says basically take everything after the R and give it to and get the register from it. Here it says get everything from the value and get it from it. So let's actually new. I want to change this to uint 32 3 0 0 0. I also set these all to 0 to start with. Okay, so we have get register, which gets the register or value, and then the remaining two are going to be registers. So we'll have get values 0 equals get register args1 dot substring 1, and then values 1, or this is going to be 1 because we want 0 to be the source 1, register source 1, which is going to be the first argument. The third argument, a register, rs2, or a value. And then finally, the destination, register destination, get register, args2, args0 dot substring 1. So now, actually, let's change this to uint 32 destination equals 0, uint 32 source 1 equals 0, and uint 32 source 2 equals 0. So let's erase all these. So the third argument is going to be source 2, or it's going to be the value. So rs2, so we're going to say source 2, and we'll say source 2 here as well. And then we'll say source 1 equals args1, get register args1 dot substring 1, and then destination equals get register args0 dot substring. And then what we'll want to do is if we have so let's put this at the end. So we have that. So let's paste this there for now. But now we want uint32 response equals 0. So we want source 1, destination, or source 2, destination, destination. So we can shift source 1 over, and we can shift it over. We have 21, 22, 23, 24, 25. So we have 5. So we want to go from 0, 1, 0, 1, 2, 3, 4. So we want to shift over 21. So source 1 response equals source 1 shift 21. And then, so that puts that in there. So that's good. So now, if we have a register in source 2, that means it's an R type. So we want to shift response or equals source 2 shift left 16, and then response or equals destination 11. If we don't, then we want response or equals destination shift 16, and then response or equals source 2, and then return response. So this basically says if we have a value, return the value, because it's going to go in the last ones regardless. And then we get source 1 destination, and we shift 21 response source 1 because it's always going to be first. And then we check if it's an R type because it's got R for the third register for the third one. So it's going to say R type instruction. And this is going to be a I type instruction. And then it just returns the response once it's been modified. So that'll get returned to args, and then we want binary lines dot add args. Actually, that's not true. That's only going to have us the arguments. So that gives us the arguments, and then we want so we'll get the opcode. So uint 32 op equals get opcode, and then we'll go if op equals 0, then we're going to have uint 32 instruction equals 0, instruction equals or equals op shift left 26, and then we're going to go instruction or equals op shift left 21, is it? Actually, that's not sure. We go instruction or equals args shift left 6, and then instruction or equals, and then we'll get func code opcode. So this is going to shift it over 6 so we can put the opcode in, because it'll be 0, so it'll all be zeros there anyways. And then if it's not 0, then we want instruction or equals opcode, or op shift left 26, and then instruction or equals args. And then we want binary lines dot add instruction. Okay, so if we breakpoint here, now it'd be nice to assume that we were going to get the right values. let's run it and see what we get for each value. So we're watching instruction. Alright, so we get that. Let's punch it into a converter. Punch it into our converter. Paste it in. And we will paste it into here. And then we'll go to the next one. Oh, binary lines is null, because we need to go binary equals new. Let's restart. That's still the same value, so let's continue. So that's a new value. Let's paste it in. Convert it. And paste that in here. And then we'll do one more. And let's paste it in, or copy the converted value and paste it in. So let's count out 32 from the right. So 1, 2, 3, 4, 5, 6. Oops. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Oh, this should be 6. And these can all be removed. So that should be 20 and 32. Perfect. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Sorry, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4, 5. 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Okay, so these are a little bit different, so let's go back and actually change these to what they are. So this is R type, which is right. So this is I type, where it's the last 15 that are connected. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Then we have 1, 2, 3, 4, 5. Just destination, right? I think that's destination. 16, 17, 18, 19, 20, 5. 1, 2, 3, 4, 5. Then we have source 1, which is 5. 1, 2, 3, 4, 5. And then we have this, which is 6. 1, 2, 3, 4, 5, 6. So 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Actually, be 16, so these should be moved over 1. So that 0 should come back. Okay. So this is actually 26, so 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. Alright. So that's how they should look. So let's see what these are right now. So this should be 0, which it's not, so that one's wrong. This should be R1, which is wrong, R2, which is wrong, and R30, which is wrong, 0, which is right, and the add function, which is right. Okay, so this one, add I. That is correct. That is correct. This should be R30, which we get binary to decimal converter, because I'm too lazy to do that by myself. We get 1, 2, 3, 4, 5, 30. Okay, so that's right. And then this is 10. 8, 4, 2, 1, 10. Okay, so now if we look at jump, this should be the opcode. Jump is 2, which is right. And then if we convert that to decimal, we'll get 11010, convert it, we get 50. Perfect. So these are correct. It's just the R type that's wrong. Alright, so let's go back to our converter. Let's stop. And let's look at just the first instruction. So let's start. So let's step over, get opcode. Opcode is add, so that should be 0. Perfect. Alright, let's step in. So line is oh. Did we? No, we wrote spaces in. Okay, so let's step over. Trimmed is the same thing. Args is now R30, R1, R2. So destination is going to be 0. Source 1 is going to be 1. So let's see. Args.length is 3, so that'll skip over. Alright, so args 1 is R1. So that should give us 1. So 30 should be args 0, substring 1, which is 30. So if we look at 1E, and if we copy that, so that's 30. Okay, so this is actually 30. So now we want to put it into 25. So we don't want to shift it 21. We want to shift it okay, so source 1 is 1. So what's response now? Response is 0. So step over. Response is 0, 0. So let's go hex to binary. So if we get 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Actually, let's do this exact same way it's done here. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So 21. So that is right so far. Okay. So now let's step into this. So args 2 is R2. So now source 2 is 2. So response is now 2, 2. So 0, 0, 2, 2, and then 4 zeros. So that means 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 16, yeah, that's right. So destination is 11, which makes response an F there now, because it's 30. Perfect. Okay, so let's see, we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So let's copy this now, and let's paste this in. So this is just our instruction, or our arguments, which is what's going to be returned. So if we have 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. Okay, so that's right so far. Oh wait, I know what's wrong. So we should now be able to just take this instruction, or equals args, and then, so now if we start this, So args should be 22F00, which is right. So now if we step in, so instruction will equal 22F00, and then instruction equals 20, convert, copy that, paste it here instead of that. So now if we go 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. There we go. Just like that, we have our proper everything now. Just like that. So we can stop this now. And it even ignored our comment lines like we wanted it to. So now, if we don't save, and we open test, and we delete these, oh. So then if we save that and run this, or line, let's go line, let's try restarting this now. This is just this is getting those Alright, so there, now I caught that. So there's just those things where it's just the blank line. So now if we open binary, some weird characters, that's a good sign. If we open up our folder, and we go to where our binary file is, if we copy it over, it's got our binary, which is what we want. So this will now convert into binary. So there we are. That's a very simple assembly to binary converter. So we can now write our text file as long as we want, as much as we want, doing whatever we want, and it'll implement it. So that's where we'll stop at this video. And next video what we'll do is we'll open up DLX simulator, and we'll write out our file handler. I'll go to the source file. Instead of hard coding these in, we are going to read in one word at a time and insert it into memory the same way, and then go through and execute that. So that'll be what we'll do next time. We'll write the file reader, we'll read the file, and then we'll test to make sure all of our stuff works. And then after that, we're ready to start making our simulator more advanced. And we'll add multi-cycle and executing instructions in a multi-cycle. We'll add handling of... Actually, we'll see what happens after that. That's what we'll say we'll do next. So next time we're going to read the file to memory, and then we'll write the instructions to memory, execute the instructions, and then turn this into a multi-cycle data path with executing multiple instructions at the same time. But until next video, happy programming.